All right. So starting with our first topic, that's the topic of your speed, velocity, and acceleration, right? Now, when we talk about our, before we talk about our actual topic of speed, we talk about, your velocity, we talk about any of that, we have to first understand that whenever I talk about any quantity, whenever I talk about anything in physics, it can be of two particular types. Anything, any quantity that I'm mentioning, I'm talking about time, I'm talking about speed, I'm talking about energy, anything I talk about. So we can take a quantity and we can put it into two categories. Either I can call it a scalar quantity or I can call it a vector quantity, right? I have two possibilities. Either I can take a quantity and call it scalar, or I can take a quantity and call it vector. What is the difference, right? When are you going to call a quantity scalar and when are you going to consider it vector? Any quantity that has a magnitude means a value, meaning it has a numerical value. Any quantity that has a numerical value but no direction, that quantity is a scalar quantity. For example, time. If I ask you, Marwa, what's the time? You're simply going to give me the numerical value. Miss, it is 3 p.m. right now. It's 2 p.m. right now, right? Are you going to give me a direction? Miss, it's 3 p.m. in the future, right? Exactly. You're not going to give me a direction. So time would be a scalar quantity. If I said, can you tell me what is the mass of the object? You would simply say that mass of the object is 10 grams. That's it. You're not going to tell me what is the direction of it. So any quantity where you have a numerical value, which is, so the numerical value is called magnitude. So any value that has a numerical value or a magnitude, but it does not have a direction included in it, that particular quantity will be known as a scalar quantity. Examples of scalar quantity: mass. When I talk about mass, you're going to give me a numerical value and that's it. Volume, again, only the numerical value is what we're going to be considering. Speed. Speed is a numerical. When I ask you for speed, you give me your numerical value. I'm traveling at 10 kilometers per hour. I'm traveling at 10 meters per second, right? We have a distance, time, right? All of these are quantities that only have numerical values and no direction associated with it. Now,
Teacher, what if I tell you about distance, but I tell you in which direction?
Distance is a scalar quantity. 1 second. I will go over distance. 1 second. I'm going to tell you about it. Distance is a scalar quantity, and I will tell you why as well. 1 second. Before we do that, let me first tell you what is a vector quantity. A vector quantity is a quantity that has both a numerical value as well as a direction associated with it. For example, you are applying a force, you're pushing an object. So not only are you, if I ask you how much force are you applying, you will say, ma'am, I'm applying 10 newtons, for example, and I'm applying it forwards. So you have given me a value as well as you have given me a direction that I'm doing it forwards, right? Similarly, if I take my speed and I add direction to speed, I won't call it speed anymore. Now I will call it velocity, right? So if you just tell me, if I ask you speed, you will say 10 meters per second. That's it. You give me a value. But if I say, what's your velocity? You will see it's 10 meters per second and I'm traveling towards the north or I'm traveling towards the south. You are now giving me a direction, right? So when I take the same speed and I add a direction to it, it becomes velocity. And velocity is a vector quantity. Similarly, distance. What if I add direction to distance? I say how much, so when I add a direction to distance in physics, I won't call it distance anymore. I will call it displacement. So if I just want to know the numerical value, how much distance have you covered, I will simply say, can you tell me your distance? You will say 10 meters. But if I say, what is your displacement? You will say, my displacement is 10 meters towards the north, 10 meters towards the south, 10 meters towards the east, right? So distance, so when we talk in English, we use distance for, as you know, both when I ask you distance, you can give me direction as well. But in physics, if I take distance and I add magnitude to direction to it, it will be called displacement. So in physics, distance is a scalar quantity, meaning that if a past paper question asks you to give a distance, all you have to worry about is the value. If they ask you to give a displacement, then you do have to consider that you do need to include some kind of direction with it as well, right? Similarly, mass is a scalar
Okay, teacher.
quantity. If I add direction to mass, it becomes weight. The weight, our weight is
Teacher, how do
always
you add
acting
direction to
downwards
the
towards the
mass?
earth's surface. Okay, like I said, when we talk about weight, whenever I am standing on the surface of the earth, if I ask you, where is the weight of the person acting, or how is the
Teacher,
weight
it's
of
like
the person
going
acting?
downwards, like to the
Yes,
gravity.
exactly. You're going to be saying it's going downwards towards the gravity. So weight becomes a vector quantity. Mass does not have any uh, 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 direction at all, right? And when we are going to do the topics later on, you will see that mass remains the same. It doesn't matter where I go. My mass remains the same. When I go into space, I will not lose my mass. What will I lose? I will lose my weight. Why? Because weight depends upon gravity. Since weight depends upon gravity, so it acts in the direction of gravity. So that's how weight has a direction. It's going to be acting towards the wherever the gravity is acting. If I am on Earth and if I'm on Mars, my mass is the same, but my weight will be different because my weight depends upon gravity. If I go into space, I don't lose my mass, I lose my weight because there's no gravity in space, right? So mass is a scalar quantity, weight is a vector quantity. Similarly, speed is a scalar quantity, velocity is a vector quantity. Distance is a scalar quantity, displacement is a vector quantity. And later on in our syllabus, we're going to study lots of different quantities. You're going to see that, and then you're going to learn more quantities, further quantities that are actually scalar or vector. Now, when we talk about scalar and vector quantities, why it is important for me, for you and me to study about them? One reason I already told you is because we need to know whether we are just calculating the magnitude or are we also worrying about the direction. The second reason for it is that in a scalar quantity, I can simply add them up. I can simply add the two values up, or I can simply subtract the two values. That's it. I just need to add, I just need to subtract, right? Meaning that if I say that there are two cars, there's a car that is covered a distance of 10 meters, and then it, uh, okay, like this. Let's say we have a car, it covered a distance of 5 kilometers, right? Then
Okay.
it stopped at a point A. After stopping at a point A, it takes a U turn and it travels 3 kilometers and it comes back to point B. Now, if I ask you what is the total distance, so the total distance is a scalar quantity. All you have to do is simply add them up. 5 plus 3 is 8. And you will tell me the total distance is 8 kilometers. That's it. Problem solved. This is distance. But What if I put this exact same scenario in front of you and then I said, Marwa, what is my displacement? Now, displacement is a vector quantity. Since displacement is a vector quantity, I now need to consider the direction in which the car is traveling. So if the car is traveling, initially the car is traveling towards the right side. So I will say the car is traveling plus 5 kilometers. After that, the direction of the car changes. How am I going to show in physics?
Should you
How
make it minus?
Yes, I will write down minus 3 kilometers. So when I write down minus 3 kilometers, what is that telling you? That the 3 kilometers are being covered in the opposite direction, right? And now if I say, can you calculate the total displacement? So you will say 5 plus minus 3.
Minus
So it
3.
will be, yes. So it will become 5 minus 3. You will actually end up getting 2. So can you see that the actual distance and the actual displacement are quite different from each other? That is
Yes,
because
teacher.
in distance, we were not looking at the direction, right? We were not
Direction.
caring about the direction. We were simply adding up the total values. A displacement is basically so another way of defining, another way of giving the definition of displacement is shortest distance between 2 points.
This is the definition of displacement.
Yes, displacement.
Definition.
Distance is the total length, right? Total
Yes.
length that is covered by a moving object, whatever the total length is. Displacement is the shortest distance between any points.
Between 2 points.
That's the definition for it. And so when I'm finding displacement, I need to take a look at the direction as well, right? So this is the difference between scalar quantity and vector quantity. Scalar quantity can be calculated using simple arithmetic. In vector quantity, we will have to take a look at direction. And later on, when I go over the topic of vectors with you, you will see that sometimes, so over here, everybody's traveling in a straight line, right? The car was traveling in a straight line. What if the car was traveling at an angle? What will you do then? So again, then we have to solve it. Why? Because this is a vector quantity, right? So we have to solve our vector quantity. So how we are going to do the solving portion, that we will study when we do the topic of forces. Then we will understand or go over how we can actually solve our these vector diagrams. But for scalar quantities, we can use simple arithmetic to solve it. But for vector quantities, we are going to have to go ahead and actually make a vector diagram and solve it in a certain manner. We can't just simply add the values up. So that is the major difference between scalar quantity and my vector quantity. Okay, this is another way of understanding distance and displacement. So I have a car that is going from point A to point B, meaning that it's this is the road. Okay, so this entire total length of the road, this is the distance. The entire total length of the road is the distance. But if I draw simply a straight line between point A and point B, this will
This
be
is displacement.
Yes, exactly. That is displacement. This is the shortest distance. The shortest distance I can have between A and B is exactly. Similarly, if I'm traveling from P to R, so from P to Q and then Q to R, this is going to be my distance, the total length. And then if I draw a straight line between P and R, that is displacement. So that's the difference between distance and displacement.
Yes.
Now, when we talk about our speed and velocity, so for speed and velocity, again, we are going to see our difference in terms of definition. Speed is a scalar quantity. Okay, so you will see that in our definition. First of all, what is speed? Speed is distance per
Speed.
time. If I take my distance, if I take distance and I go ahead and I divide it by the time, I am calculating the speed, because distance is a scalar quantity.
Teacher, I can't hear you now.
And divided by time. If I'm calculating speed, I will take the distance and I will divide it by time. Now, another definition
Did you hear me?
yeah. Go on, Marva.
You can just repeat what you said because your voice stopped and then it started
Oh,
just again.
okay, all right. I was saying speed, the way we are going to define speed, the definition of speed is distance per unit time. How much distance are we covering per unit time in 1 second, for example, right? So
This
I
is the
take my,
formula.
yeah, and this is the formula. The definition is the same. If they ask you to define speed, simply write down distance per unit time. And if they ask you to write down the formula, that is exactly the same, distance per unit time. Often in physics, you will see that certain definitions are quite similar to the formula. In physics, a lot of the definitions are actually the same as the formula of the quantity. So if you learn the formula, you can often write down the definition according to the formula. So speed is equals to distance upon time. And if they ask you to define it, you can simply say distance covered per unit time. Velocity is displacement per unit time. So we have distance, but now we have added direction to it. So it has become displacement, right? It has become displacement. So when I take the same displacement and I put it over the same time, I will now call it velocity. So if I take the distance and I divide it by time, that's speed. But displacement per unit time is going to be velocity. And then we have another terminology that you have to study in this topic, and that is acceleration. What is acceleration? Acceleration, easy way to understand it. This is not the definition, but this is the way to understand. Acceleration is how quickly is the speed of your car changing. For example, let's say it's going 1, 2, 4, 8, and then it's going 1, 4, 8, 12. Now, over here, our speed is increasing, but it is increasing multiplied by 2.
This is the acceleration.
Yes, acceleration is how fast, 1 second. Acceleration is how fast the speed is changing. How fast is the velocity changing? So acceleration is change of velocity, right? There is velocity is changing place. Your velocity is changing. Your velocity is increasing. But how fast is it increasing? Is it going from 1, 2, 3, 4? So is it increasing by plus 1?
1.
Or is it going 1, 4, 16? Right? You can see. So over here, the car is accelerating more because the speed of the car is increasing, but the increase is greater. In the first scenario, again, in both situations, I can see acceleration, because in both situations, I can see that the speed is changing. But again, how fast is it changing? Is it changing by plus one, plus one, plus one? Or is it changing by multiply by four, multiply by four, multiply by four, right? So it's about how fast the speed is changing. It's not just about the speed changing. It's about how fast the speed is changing. How quickly is the speed changing, right? So
Right.
the way we define it is that we say acceleration is the rate of change of velocity. Rate means time. Whenever I include time into it, I will call it rate. So acceleration is rate of change of velocity.
Of
Again,
velocity.
see, I'm saying velocity. If I'm saying velocity, that means acceleration is going to be a vector quantity. Velocity is a vector quantity and acceleration is also going to be a vector quantity. How do I calculate acceleration? What is the formula for acceleration? So the formula for acceleration is change in velocity divided by your time. Now, when we talk about change in velocity, how can I calculate the change in velocity? To calculate the change in velocity, you will simply take, so I have a car going from point A to point B. It starts off with a speed of 10 meters per second and then it gets to 20 meters per second. So if I ask you what is the change in velocity, you will simply take the velocity at the very end.
Very end.
We call it, yes, we call it final velocity. We call it final velocity and the symbol is V.
V.
And
And addition.
yes, you will take the velocity at the start. The velocity at the start is known as initial velocity and I will call it U. So I will subtract the two of them and that will give me the change. So I will take my initial velocity, I will subtract from it my final velocity, and whatever answer I get, I will simply divide it by the time. This is the formula for acceleration. So acceleration is change in velocity divided by time, right? And when I subtract the two, the final and the initial, I will get my change in velocity and I divide the answer by time and that will give me my acceleration. Now, what is the unit for acceleration? The unit for acceleration is meters per second square,
Meter per second.
right? So if you want, I can actually tell you how we are getting the unit. Look, we know that velocity is equals to displacement over time. Displacement is going to be measured in meters, right? And time is in seconds. So velocity, the unit of velocity, the unit of speed is meter per second. Now, when I'm calculating acceleration, I am again taking my change in velocity. This triangle means change. Okay, it's a Greek symbol. It in the we call it delta. Okay, so whenever you see delta V, delta F, so delta simply means change, right? So change in velocity, and I'm going to be dividing it by time. This delta symbol is not just for your physics. This can apply to chemistry. If you're doing mathematics, you can apply it over there as well. So delta V upon T. Now, velocity is, what is the unit for velocity? Meters per second. What is the unit for time? The unit for time is second. Now,
S.
yes. Now, what is happening over here? We are dividing two fractions by each other. Now, if you've covered fractions in mathematics, you might remember this. And even if you haven't, I'll tell you. Whenever you see that there are two fractions dividing each other, we always take the lower fraction, we flip it upside down, and we put a multiply sign in the middle, meaning this is meters per second. This is second, right? So basically, what am I going to do? I'm going to write down multiply and I'm going to turn it upside down. When I'm going to turn it upside down, it's going to become 1 upon second. Meter multiplied by 1 is meter. Second multiplied by second is second square. And that is how we get the unit for acceleration. So the unit for acceleration is meter per second square. Okay. Now we know acceleration, we know velocity, we know speed, we know distance, we know displacement. Now, what you have to remember is this. In your exam, you are going to get two types of graphs from where you have to be able to find all the required information. The two types of graph that you're going to be dealing with is going to be displacement or distance. It can be anything. Normally it's displacement time graph, where you will have displacement on the y-axis and distance on the x-axis.
Teacher.
Yes.
So teacher, this is like what the graph look like?
Yeah. Not necessarily. It can look like anything at all, depending upon the question. But we are going to use this graph to understand all the possible questions you can get with. So the shape, the shape of the graph, that can look like anything at all. But on the y-axis, you will have displacement or distance. And on the x-axis, you will get your time, right? This is one type of graph. The second type of graph that you will see in your exam is speed time or velocity time graph.
Speed time
Now,
or velocity time graph?
yes, exactly. We are going to study both of them. The reason I'm telling you is because when you are solving your questions, always pay attention to what graph is in front of you. Because depending upon which type of graph is in front of you, the way you're going to solve it is going to be different. We are first going to start off with a distance time graph or a displacement time graph. Over here in this particular graph, distance is given in kilometers and time they have given us as 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. You can see different things. They can give you distance in meter. And then when you talk about the time, they can give you 1 second, 2 second, 3 second, 4 second. So the units can be different. In this particular situation, we have 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, so on and so forth. Now, first thing is first. In a distance time graph. So in a distance time graph, if I want to find out the distance traveled by the car, all I have to do is just read the graph, right? If I ask you what is the distance traveled by the car in 2 hours, so you will say, okay, I started at 9 o'clock. 2 hours mean that it will be 10 o'clock, 11 o'clock. So at 11 o'clock, what is the distance? Oh, the distance is 30.
It's
So the
30.
distance is, distance is 30. So in a distance time graph, if they ask you to find the distance, it's nothing to worry about. Simply read the graph, look at the y-axis, find the value. But
Okay, teacher.
there's
And
another
what are
piece.
these? Like this gradient is equals to speed, and then steeper is fast, and flat is
Yes.
stopped.
Yeah. I know. I'm telling you. Hold on. So in a distance time graph, one information you have is of course the distance, how much distance the car has traveled. You can always read that by using the graph. Now, the distance time graph gives us another piece of information. The piece of information it gives us is that it also tells us about the speed of the car. How is it that this particular distance time graph or any distance time graph is telling me about the speed? How can I calculate the speed from a distance time graph? I do that by calculating the gradient. Now, if you have done mathematics, you might already know about gradient. If you haven't, that's fine. Gradient, the way you can define gradient is the steepness or the slope of a line.
Slope of the line.
Meaning that I have two lines. One line is a bit flat. One line is a bit steep. It's at a higher angle. So the line that is steeper, the line that is higher, that line has a higher gradient. The line that is flatter, it has a lower gradient, right? So it tells me, what is the gradient? Tell me how steep my line is. Is it at a high angle or is it at a low angle, right? It tells me about how steep my line is. So if I have a line, for example, that is completely flat, the gradient is 0. Why? Because it has no slope. It has no steepness. It's flat. At the same time, if I have a line that is completely vertical, completely straight, the gradient is infinite. The gradient is infinite. It's an infinite value. Why? Because it's completely steep. It's completely vertical. So a gradient always tells me the steepness or the slope of a line. How can we calculate a gradient? The formula for gradient is either you can learn it as rise over run, or the way I like to say it,
Rise over.
y-axis. Yes, exactly. Y-axis over x-axis. Meaning, I take the value from the y-axis, I take the value from the x-axis, and I subtract them. Let's see how we can do that. So let's say I give you, so first things first, let's say I ask you to calculate the gradient of the red line. Okay. Step number 1, find 2 points, any 2 points on the red line. So let's take this one and let's take this one. Let's take 2 easy points. Okay. Now, step number 2, write down the coordinates. What are the coordinates? The coordinates are what value is on the x and what value is on the y. On the x, it is written 9. So I will write down 9. On the y, it is 0. So I will write down 0. First, we write down the x and then we write down the y. Over here, if I take a look, on the x, I have 11. On
and
the
then we
y,
have 30.
I have 30. After writing down these coordinates, I will then calculate the gradient. The gradient is like this. Y2 minus y1 divided by x2 minus x1. Over here, I have 2 coordinates. Let's call this coordinate number 1 and this is coordinate number 2.
Coordinate number 2.
So, yes. So what am I going to do? I'm going to take the y2. So coordinate number 2 and I'm going to take the y. So the coordinate number 2, y is 30. Then I need y1, which is coordinate number 1, y. So coordinate number 1, y is 0. Then x2, so coordinate number 2, x, that is 11. Minus coordinate number 1, x. So coordinate number 1, x is 9. So I will end up getting 30 upon 2 and that will give me 15. Right? So this is the gradient of the line. This is how you calculate the gradient of the line. And what is the gradient of the line telling me right now? It's telling me that my speed is 15 meters per second. That my speed is 15 meters per second. Right? So in a distance time graph, we can calculate the speed of any object simply by calculating the gradient of the line. Now, when we talk about the gradient of the line, there are certain informations that we can get simply by looking at a graph. When you solve your paper 2 especially, you will see that in paper 2 they have given you questions where the graphs don't have any value. There are no numerical values in the graph. They've just drawn a shape and they're asking you questions about it. So a few things we can figure out simply by looking at the shape of the graph, right? One thing is the calculations. Then we can figure it out simply by looking at the shape of the graph. What does that mean? That means that when I talk about a distance time graph, and in my distance time graph, I see that I have a straight line, a completely straight line, right? I can see that I have a completely straight line. What does that tell me about speed? So one, I can calculate the speed, but what other information does it give me about speed? The information it gives me about speed is that it tells me the car is traveling at a constant speed. What do I mean by constant speed? You can say constant speed or you can say
Teacher, like the normal speed is moving on.
yeah, basically the speed is not changing, right? Meaning that if the car over here, we got the value of 15 kilometers per hour. So what is going to happen? That it is traveling at 15 kilometers per hour throughout. The speed is not changing. There is no change in speed. If there is no change in speed, then there is no acceleration. The car is not accelerating. The car is not accelerating. It is traveling at a constant speed, constant or uniform. You'll see both words in your past tense. It is traveling at a constant, uniform velocity. It's not changing. The value is not
So teacher, there's
changing.
no acceleration at like this
Yes,
red
simply,
line,
yes,
there's no acceleration.
exactly. Simply, there is no acceleration. So whenever you will see a straight line, right? A straight line with constant gradient, right? Whenever we have a straight line like this, we say that the gradient is constant because it doesn't matter what 2 points I will take on the line. I will get the same gradient, right? It doesn't matter what points I take. I will always get the same gradient. So that means this line, this straight line, the gradient is constant. The gradient is not changing. The gradient is the same throughout any 2 points, whether I take this or this, or this or this. You can take any point at all, you'll always get the same value of gradient. So a straight line always have a constant gradient. And our gradient in the displacement time graph, our gradient is the speed. Our gradient is the velocity, right? Velocity, speed, velocity. So since our gradient is not changing, our speed is not changing. So whenever you will see a straight line on a distance time graph, what is that going to tell you? Speed is remaining the same. The car is not.
It's not moving.
No, it is moving, but it's moving at the same speed.
Oh, it's moving constantly. And teacher, when it's the flat line, that means like this car stops.
Yes, exactly. I'll tell you 1 second. So basically, it means that there is no acceleration and the car is traveling at a constant speed. Now, how would the graph look if it was accelerating? What if the speed was changing? What if it was going 15, 16, 17, 18? Then how would you see in the shape of the graph? The shape of the graph would look like a curve. So if you have a distance time graph, and on the distance time graph, you will see that the line is a curve. That means that the speed is not constant, acceleration is present. Now, how can you do calculations with the curve? That's not in your syllabus. That you don't have to worry about it. That's not in your syllabus. The only thing is that if they put two graphs in front of you, one graph is like this and one graph is like this, and they ask you which graph is showing you constant speed, it's this graph. So oftentimes in paper 2 questions, they don't give you numerical values, they'll give you the shape of the graph. And then they will ask you questions on it. So all you have to remember is that if it's a straight line, that means the speed is constant, meaning that the speed is not going to change. It's going to be moving at the same speed throughout. But if you see a curve on a displacement time graph, I'm again emphasizing the type of graph, right? If you see a curve on a displacement time graph, that means that the speed is not constant. Now,
But
calculations related to it are not a portion of, are not anything you have to worry about. That's nothing to do with you. But if you take a look at if you see a curve, that will automatically tell you the speed is not constant. Now, what happens if I have a situation where the gradient is 0, right? Where I have a straight flat line. Now, if I have a straight flat line, that simply means my car has stopped. And even you would be able to tell me my car has stopped without doing any calculations. Why? Because the distance is not changing. The distance is remaining the same, 30, 30, 30, 30. At 11 o'clock, the distance covered by the car was 30 kilometers. 1 hour later, the distance is the same. If the distance hasn't changed, then of course the car is not moving. If the car was moving, the distance would be increasing. Distance is remaining the same. Distance is not changing. What does that tell us? The car has stopped. The car has stopped moving. And if you decide to do calculations, if you say, no, I want to do calculations and make sure, so again, you can calculate the gradient of the line. And you will see the value for gradient is 0. Why is it 0? Because I told you.
car stopped.
Yes, because a completely flat line has no slope. A completely flat line has no steepness. There's no slope. It's flat. So gradient is 0. And gradient is equal to speed. So that means the speed is also 0. The car is simply stopped moving.
Okay.
Next. Now, what if you have a graph where you have 2 lines? Okay. One line is this one, the one I've already highlighted in blue. And then we have this one. Now,
teacher, it means first it was moving at the constant speed, but then it's like the speed increased.
the speed increased. It is still traveling at a constant speed, but the speed is now greater. The constant speed is not gone. The constant speed is still there. If the constant speed had changed, if you had gone from constant speed to changing speed, you would see a curve. Remember that. Whenever the speed is changing, meaning whenever I have acceleration, it will be a curve. The fact that it's a straight line tells us that it is still constant speed, just the value for speed is now greater. First, it was traveling at 15 kilometers per hour. Now we can do the calculations. Again, we can calculate the gradient of the line, right? Again, I can take 2 points and I can calculate the gradient of the line. So over here, again, let's see. X is 12 and Y is 30. Over here, X is 12 is basically 12.5. I'm going to take it as 12.5 because it's over here.
Yes,
And the Y is 60. Right? So again, I can go ahead and I can calculate the gradient using exactly the same thing. I can do Y2 minus Y1, 60 minus 30.
Minus 30 will be 30.
And 12.5 minus 12.
Minus.
So I will end up getting 30 divided by 0.5. And you can then do the calculations, right? So
Right.
when we go ahead and we talk about it, you will see that the value you're getting is going to be much higher. Why is the value we are getting much higher? The reason the value we are getting is much higher is because the gradient of the line is now higher. It's still constant speed. It's not acceleration. We are still not seeing any acceleration because the line is straight. Because the line is straight, that means we still don't have any acceleration, right? But since the gradient is higher, that means my speed will also be higher. Meaning that if they give you a past paper question where they put a line like this and they put a line like this and they don't give you any value. And they say, just looking at the graph, can you tell us which car is moving faster? So all you need to remember is that greater the gradient, greater the velocity. So whichever line,
graph too?
Sorry?
The second one. I think the second one you draw, I guess, move faster.
Yes, exactly. This one. Second one has a faster slope, right? It has a greater gradient. So this
Yes.
is the one greater speed, right? So what you need to remember in a distance time graph is that in a distance time graph, the gradient is equal to speed of the object. If you see that the line is completely straight, the gradient is constant, that means that speed is also constant and there is no acceleration. If the line is completely flat, that means our car has stopped. It's not traveling at all. And the faster or the higher the gradient, the faster your car is moving. The higher the gradient, the faster your car is going to be moving. So this is the
Okay.
information you can judge from this particular graph. These are all the information you will get from your distance time graph. Now, we have another type of graph, and that is velocity time graph or speed time graph. Now, the reason I told you is whenever you're solving past paper questions is that you always have to remember, or always first thing is look at the type of graph in front of you. That's the first thing you want to do. What type of graph is in front of you, right?
It's velocity
Because,
time graph.
yes, because in a distance time graph, the gradient was equal to speed. But
Yes,
in a
because of
velocity time graph, the gradient is equals to acceleration.
acceleration.
Yes. So same gradient will mean something else. Same lines will now mean something else. That's why you always want to pay attention to what type of graph you're looking at, right? Because the same thing, exact same thing, but it's going to have a completely different meaning when we talk about our velocity time graph. So in our velocity time graph, if I want to know the speed of the car, I will simply read the graph. Like over here, I said, if you want to know the distance, read the graph. What is the value on the y-axis, right? Simply read the graph. Now
Yes,
over
teacher.
here, if I want to know the speed, if I want to know the velocity, read the graph. What does the graph say? Plain and simple. Now, what if I want to know the acceleration? Now, if I want to calculate the acceleration, I will calculate the gradient of the graph. And I will do it in the same way as we have studied. I will take 2 points on the graph, right? After taking the 2 points on the graph, I'm going to go ahead and I'm going to use my formula. Over here, the coordinates are 0, 0. Both y is 0 and x is 0. Over here, x is 4 and y is
And y is 3.
and then I'm going to use my formula. Y1 minus y2. So that
2,
will become
3.
3. That will become,
Did it's going to be 3 or 4, the final answer?
yeah, that will become, 1 second.
Teacher, is it okay if I just my answers are in decimal or something? Does that really
Yeah, it's
matter?
fine. Yeah, it's fine. You can do that. And then 4 minus 0. So you will get 3 upon 4 or you will get 0.75
0.75
meters per second
per second.
square,
Wow.
right?
Yes,
So
teacher.
that is how you're going to calculate. So the same thing. This is why I said which type of graph you're dealing with is really important. Because if you're calculating the gradient of a distance time graph, you're calculating the speed. But if you're calculating the gradient of a speed time graph or velocity time graph, you're actually calculating the acceleration. So the same thing, we are still calculating gradient, but that gradient now has a different meaning. That's why it is so important for us to remember or pay attention what kind of graph we are looking at. Again, we are dealing with a straight line. I said that whenever we deal with a straight line, that means our gradient is constant, right?
Yes,
If the
teacher.
gradient is constant, so that means our acceleration is constant.
Constant.
Again,
This is for
in a,
velocity, right?
yes, velocity is not constant. Velocity is changing. Velocity is going from 0 to 3. Velocity is not constant. That's exactly what I'm saying. In a distance time graph, the straight line meant velocity is constant. But if I take a velocity time graph, now it's not velocity that is constant, it is acceleration that is constant. Meaning that if my speed was 0, then from 0 it went to 1, then to 2, then to 3. So it's increasing by +1. This is constant. That my speed is increasing, but it's increasing by the same value. It's increasing by +1. What if I had 0, then 1, then 4, then 9? So first it's increasing by +1, then it is increasing by +3, then it is increasing by +5. So over in both the situations, my velocity is increasing. But in the first situation, my velocity is increasing by the same number, by the same value. This is constant acceleration, that my car is accelerating, my speed is increasing, but the speed at
So
the
the
rate,
same number.
yes, exactly, it's increasing by the same number. This is non-constant or non-uniform acceleration. My car is accelerating, but it is accelerating at with different values, right? So over here in this particular situation, when we have a straight line, that does not mean speed is remaining the same. Speed is changing, speed is increasing, but it is basically accelerating at a constant value, meaning it's increasing by +1, +1, +1, +1. Now, what if we had a situation number 2? What if I had acceleration, but it was not constant? The velocity was increasing, but it was increasing with different values. So in that case, I would again observe a curve. So you see, if we have a displacement time graph, and on the displacement time graph, I have a curve, what does that tell us? That tells us
The
that
acceleration is changing.
no, on a displacement time graph, if we have a curve, that tells us what? That tells us that our velocity is not constant, acceleration is present. If I have a straight line, that means no acceleration, constant velocity. On a displacement time graph, if I have a curve, what does that mean? Acceleration is present.
Acceleration.
In a velocity time graph, if I have a straight line, what does that mean? Acceleration is present, and it is present, and it is constant. It is uniform. It is constant. The second scenario is when we have again acceleration is present, but this time acceleration is not constant. So in both cases, velocity is increasing. Both cases, velocity is increasing. But is it increasing by a fixed value, or is the value changing? So if it's increasing by a fixed value, constant value, it's a straight line. If it's increasing by different values, it will be a curve. And if the graph is this one, the distance one, in that case, a straight line means that there is no acceleration. The velocity is not increasing. If it's a curve, then velocity is increasing. In this scenario, whether it's a straight line or a curve, velocity is increasing. The question is it increasing by a constant value or a different value? So if it's increasing by constant value, it's
a straight line.
Yes. If it's increasing by non-constant value, it's an acceleration. Okay. Okay, Marva, we'll go ahead and stop it over here for today for physics.